identify acids and bases using indicators and neutralizing reaction in our day-to-day life. So, in this chapter we will learn this all thing. So, let us start with what is acid. Okay? It is a chemical substance that is sour in taste. Now you see, any substance that contain acids are called what? Acidic substance. Okay? Naturally occurring acids in some fruits and vegetables make them what? Acidic. Okay? Like lemon, again oranges, tamarind. These are sour in taste, is not it? So these are what? Naturally occurring acid. And this acid make the fruit sour in taste. Now we will discuss about the types of acid. Usually acids are of two types. Okay? One is organic acids and mineral acid. What we learned from the term organic, they are made from what? Organic substance like plant and animal. Just now I told you many vegetables and fruits. What happened? They are sour in taste. Is not it? Due to what? Due to acid. It occurs naturally. Is not it? Now another is animal also secrete some acids. Okay. Now we will go to the example of some organic acids. Now you see acetic acid. It is found in rotten fruits. Okay. Citric acid. This citric acid is usually found in citrus fruit like lemon, oranges like that. Okay. Lactic acid found in milk. Tartaric acid usually found in grapes, apples. Oxalic acid usually found in nuts, green leafy vegetables. Okay. Formic acid. You may have seen when a honeybee stings you. What happens? It is very painful and swelling. It's not. Do you know why? When they bite you or enter their sting in your skin, they release formic acid, and due to that, it is very painful and swelling. Okay. So now we will come to mineral acids. What are these mineral acids and how they are obtained? These mineral acids are obtained from mineral presence in the earth crust. It is man-made, that is made by human in laboratory by using certain chemical processes. Now we will see some example of mineral acids. Okay. So these are some example of mineral acids. See. Sulfuric acid, hydrochloric acid, nitric acid, boric acid, phosphoric acid are there. Okay. So these mineral acids are highly corrosive. If you will not handle it carefully, what will happen? You may get certain burn. Okay. Especially this sulfuric acid, hydrochloric acid. While using in lab, you should be very careful because they are highly corrosive. You may get several burns also. Okay. So now we will discuss dilute and concentrated. What are these dilute and concentrated acids? Okay. Now see concentrated and dilute acids. Depending on the amount of water present in acids, they are differentiated as concentrated and dilute. So now you see what happened in concentrated. In concentrated acids, the amount of water present is very less. Almost they are in pure form. Okay. And they are highly corrosive. They are very harmful. Okay. Now dilute acid. What happened? The amount of water present in dilute acid is more as compared to concentrated acid. Okay. And usually in laboratory we use dilute acid. Okay. They are less corrosive and less harmful. Now we will discuss the properties of acid. What are the properties of acid? First of all, how you will identify whether a substance is acid or base? Acid is sour in taste. Okay? Like lemon in taste. Now, the next one is they are soluble in water. When you mix acid in water, they are soluble. They will mix up. Okay? The third one is acid turn blue litmus red. What happened? Litmus. It is a kind of indicator. This paper will tell you about whether the substance is acidic or base. It is blue in color. If you will add base here, the color will remain same. That is blue. But if you will add acid here, the color will turn red. Now you see these acids are highly corrosive in nature. Okay. So what happened? It has a tendency to corrode the metal also. So chemistry also. Okay. So what happened? They are used in this batteries. Okay, big batteries. What happened? Acids are used as an electrolyte. Now you see, acid react with certain metals to give salt. Okay. Now you see what happened. H2SO4. It is a kind of acid. It's not it. Acid. When it reacts with metal, suppose zinc is a metal. Okay. It will give what? Salt. I am not talking about salt that we eat, okay? This one is different salt. Salt plus hydrogen gas. So keep in mind that what happens when acid reacts with metal. Okay? See, this one is what? Acid. When it reacts with metal, that is zinc, it will give what? Salt. That is zinc sulfate and hydrogen gas. Okay? The reaction will be always same. The metal may vary, okay? This metal may be different, the acid may be different, but the product, okay? That is salt and hydrogen gas will be same, okay? The formula of the salt will be of course different if you will take the different elements here. Now we will discuss different uses of acid. Now first of all we will see the use of sulfuric acid, that is this sulfuric acid is usually used for what? Making fertilizers, and it is also used in the batteries. Just now I told you. This sulfuric acid is also used to remove oxide before galvanization. Now you see what is galvanization, okay? Suppose this is a metal, okay? So to give it a shiny appearance, okay? Very shiny appearance, a layer of zinc is used, okay, over the metal. That is what? Galvanization. So suppose a metal is left outside for a few days. What will happen? Rusting will take place, is not it? So to remove this odor, this sulfuric acid is used before galvanization. So that what will happen? The metal will become clean and they will put a layer of zinc over it. Now this sulfuric acid is also used for obtaining several salts like copper sulfate, zinc sulfate. Just now we have seen salt H2SO4. Sulfuric acid is not it. If it reacts with copper, what it will give? Copper sulfate. Is not it? Plus H2. Just now I told you when an acid reacts with metal, it will give salt and hydrogen gas. Is not it? So in this way, what happened? They produce several salts like copper sulfate, zinc sulfate. Is not it? Now we will see where we use this hydrochloric acid. It is usually used in refining of common salt that we eat, hydrochloride. Is not it? Now, so what happened? This hydrochloric acid is used in preparation of aqua regia also. Now you see what is aqua regia. This aqua are used when you go to jewelry shop. Okay, suppose your necklace, okay, it lose its luster property. It is not shiny anymore. So if you will go and give to the goldsmith, what they will do? They will put that jewelry inside the aqua regia. Okay. Then what happened? You will get that shiny appearance. Now you see what is this aqua regia is made up of. They are made up of 3:1 ratio of hydrochloric and nitric acid. Hydrochloric plus in the ratio of 3:1. Okay. Okay. Now see HNO3 nitric acid. Okay. Nitric acid is usually used in making explosives like TNT, trinitrotoluene. Okay, it is a chemical compound which is very explosive. Okay, and next you see it is used for making fertilizers also. Okay, like urea, and it is used for making synthetic dyes, plastic. Okay, and it is used as an oxidizer in rocket fuel. You know why? See what happened. Something will burn. A fire will take place if there is air, that is oxygen, heat and fuel. If we cut off any one thing from here, what happens? Suppose air is not there, then what will happen? The fire will not take place. So we all know that also used as an oxidizer in rocket fuels, okay, to provide oxygen. Now you see acetic acid. It is also a very weak acid, okay. So usually it is used in food preservative as a vinegar, okay. You have seen maybe at your home vinegar is present. So it is made up of what? Acetic acid. It is also used for making medicines, dyes, pesticides, okay. And in chemical laboratory, it is also used for testing your blood samples. Students, now we will discuss about base. What is base? So, base is chemical substance, okay, that are bitter in taste, okay. You don't like bitter gum, it's not it. Why? Because it is bitter in taste. When you touch them, they are soapy to touch, okay. So, any compound that contain bases are what? Basic compound, okay. So, here are some example of bases. Okay, see already I told you the periodic table, I told you to read up to 20. Okay, so I hope you all know the chemical formulas. Okay, see K, what? Potassium, is not it? And OH, hydroxide, potassium hydroxide, sodium hydroxide, calcium hydroxide. Keep in mind that wherever this OH, hydroxide is present, the substance is what? Basic. Okay. So these are some examples of bases: potassium hydroxide, sodium hydroxide, calcium hydroxide. Now see types of bases. Bases are usually of two types: strong bases and weak base. Okay, there are some examples of strong base. You see, potassium hydroxide, sodium hydroxide. They are strong base. Okay, and what happens? They are highly corrosive. If it falls into your body, what happens? You can get severe burn, or it can damage your skin cell also, tissues also, okay. Now weak base, copper hydroxide, zinc hydroxide, they are not that corrosive, okay. Now how you will identify whether a base is strong or weak? It's not, we can do this with the help of pH scale, okay. Now what is pH scale? You will learn about it in the next topic, okay. By measuring with the pH scale, we can know whether the base is strong or weak. Okay, now we will see the properties of bases. You see, bases are what? Bitter in taste. It's not it. Just now I told you bases are bitter in taste. Bases have soapy and slippery touch. When you will touch it, what happens? They are very slippery, like soap. Okay. Now you see, all bases are not soluble in water. We found that all acids are soluble in water. But in case of base, what happens? All bases are not soluble in water. But some bases that are soluble in water are called what? Alkalis. Okay, keep in mind. Bases which are soluble in water are called what? Alkali. So some alkali bases are what? Sodium hydroxide. Okay, sodium hydroxide, calcium hydroxide. These are what? Some bases that are alkali, that are soluble in water. Now what happened? Base turn red litmus blue. See what happened? Red litmus. It is an indicator. Okay. We use this litmus paper to see whether the substance is acid or base. It is red in color. What happens if you will dip this red litmus in acid? It will not change the color. But if you will put it in a base, what happens? The color will turn blue. Okay. Understood? Now you see what happens when this base react with acid. When we put base and acid together, what will happen? They will form salt plus water. Again I am telling you the salt. This is not the salt that we eat at home, okay? It is another compound form. Now you see what happens? Magnesium hydroxide, when react with magnesium hydroxide, see OH is there. It's not it, so it is a base. Now here what happens? H2SO4, sulfuric acid. It's not it. So when they react, what product is formed? Magnesium sulfate plus 2 molecules of water. Is not it? So now you see we will discuss about the uses of bases, where these bases are used. See, calcium hydroxide, usually known as salt lime, where it is used. It is used in cement factories for making cement, okay, and several plasters in walls, mortars, okay, and it So for neutralizing it, what happened? This salt gland is used. It is added to the soil, and it is also used to fill the cavities. Okay, if you have cavities in your teeth, what happened? Then it is used with calcium hydroxide to fill the cavities. Okay, now we will discuss about sodium hydroxide, also known as caustic soda. It is highly alkaline. Okay, now you see it is used for manufacturing of soap and detergent that we use. Okay, and it is also used as a cleaning agent like Harpic, okay, Lysol, these things. Okay, to make this thing, to remove the oil and grease from the floor or tile. It is also used in the purification of bauxite during the extraction of aluminum. So you may get confused in this. So what happened? You see, aluminum, it is a metal, is not it? It is not found in pure state. Okay? See what happened? It is a ore. Bauxite is an. So aluminum is mixed here together. Okay? Suppose this is a ore. So we need to separate these two. We need to extract aluminum. Is not it? We will extract this aluminum from this bauxite ore. Then we will use this aluminum for several purposes. Okay? We need to extract this aluminum from bauxite ore. All the metals present are not found in pure state. Okay? They are always found in mixture state. Later on, we need to separate them by several processes, chemical processes. Okay? Lastly, potassium hydroxide, okay, also known as caustic potash. And what are the uses of this caustic potash? It is used for making biodiesel. These biodiesel are made from several vegetable oil, okay, and later on used as a fuel. Now it is also used for making disinfectant, soap, detergents, okay. Now we will discuss about magnesium hydroxide. Okay, what is this magnesium hydroxide? It is a strong base. Okay, when we mix up this magnesium hydroxide with water, they form what? Milk of magnesia. And what are its uses? We will see. In industries, non-hazardous as a non-hazardous base to neutralize acidic waste. What happened from industries? What happened? Many waste comes out. It's not it. They are acidic in nature. So what happened if you put this magnesium hydroxide in that acidic substance? What happened? It will neutralize. Okay, acid and base will mix up together and they will neutralize it. Okay, and it is also used in several medicines. Okay, if you have too much of acidity, what happens? This Digene is given to you. It's not it. So these all are made up of what? This magnesium hydroxide to lower the acidity of your stomach. Now we will discuss about ammonium hydroxide. Okay, ammonium hydroxide is commonly known as ammonium, and this ammonium hydroxide is used as a cleansing agent in household solutions. Now it is also used in the preparation of chemicals like nitric acid, sodium carbonates. Okay, so students, now we will discuss identifying acid and base. How you will identify a acid or a base? See, it is very difficult to taste a chemical. It's not it. Whether it is sour in taste or bitter in taste. It's not it. So we need to find some more ideas. It's not it regarding this. How we will see whether the substance is acid or base. So there are special substances that help us to identify this acid or base. They are what? Indicators. These indicators help us to know whether the substance is acid or base. So there are two types of indicator. One is natural indicator and another is scientific indicator. So now we will discuss about natural indicators. Okay. So natural indicators, they are prepared from what? Petals of light color plants, flowers, leaves. Let's cite some example of natural indicator. Turmeric, cabbage, white color petals of flower are what? We can use them as an indicator. Okay. Now you see litmus. What is litmus? Litmus. Okay. Now you see this litmus is a natural indicator. It is made from the extract of lichen. Now what is a lichen? Do you know what is a lichen? It is a symbiotic association between fungi and algae. Okay. These two combine together, fungi and algae combine together to form a lichen. Okay. You see substance is acidic, what will happen? This blue litmus will turn red. Okay? When the substance is acidic and we put this blue litmus in that substance, what happens? It will turn red. And when the substance is basic, then what happens? This red litmus will turn blue. Okay? When the substance is basic and you put this litmus paper, what will happen? The litmus paper will turn blue. Keep in mind. Okay? The acidic substance turns the blue litmus red and the basic substance turns the red litmus blue. Now, let us know about synthetic indicator. What is synthetic indicator? These are indicators made by humans. Okay? So, usually there are two types of synthetic indicators. The first one is methyl orange and the second one is phenolphthalein. So, what happens when this methyl orange, the color of this methyl orange is usually orange in color. Okay, so you will see in your book that a scale is given. Okay, what happens? Methyl orange, when it reacts with acid, the color will change into red. Okay, and when it reacts with base, the color will turn yellow. Okay, keep in mind, methyl orange, that is usually orange in color, when it reacts with acid, it turns red, and when it reacts with base, it turns yellow. Okay, now you see phenolphthalein. What happens? Usually they are colorless, okay, like water. So, when they react with acid, it will remain colorless. Okay, when they react with acid, if you will add a few drops of phenolphthalein acid, what will happen? It will remain colorless. But if you will add in base, what will happen? The color will turn pink. Later on you will get it in titration. Okay? So students, now we will discuss about salt. Okay? See, a salt is a substance which forms when an acid reacts with base to give one salt and water. Okay? See. When an acid reacts with base, it gives salt. Is not it? So what happens? This reaction is commonly known as neutralization reaction. Okay? So a reaction in which an acid reacts with base to give salt and water is called a neutralization reaction. So here one example we can see. See, HCl, hydrochloric acid. It is an acid. Is not it? And sodium hydroxide, OH is there, is not it? Base. When react together, they give what product? Sodium chloride plus water. Is not it? So, what is the salt here? Sodium chloride is the salt here. Okay? Now you see, in a neutralization reaction, this potassium, okay, and carbonate. So to remove this all thing, what happened? The sodium carbonate is used to neutralize it, okay. And this sodium carbonate are also used for making glass, okay, glasses, papers and all. Now see sodium bicarbonate, okay, we will also known as baking soda. It is also known as baking soda. And where we use this baking soda? Usually at our home, is not it? While baking. And it is also used as an antacid. When we have too much of acidity, it is used as an antacid also, okay. And the sodium bicarbonate is also used as a soda acid fire extinguisher, okay. Now we will discuss about copper sulfate. It is usually blue in color, okay. Now you see this copper sulfate is used as a coloring agent for making several glasses, okay. Window glasses, sometimes it is in blue color, different colors are there, not it. So copper sulfate is used as a coloring agent for making different colors of glasses, ceramics, okay. Now it is also used for making fungicides, okay. So usually in rainy season, our surrounding, okay, what happened? There are lots of fungus, not it? So you can use this copper sulfate to remove all that. It is also used as a preservative for woods, okay. If you have wood pillars at your home, what happens? If fungus will attack, okay, many insect fungus may attack, and what happens? The wood may become weak, is not it? So this copper sulfates are used as a preservative there. Now we will discuss about the application of neutralization reaction in our day-to-day life. So the first one you see, insect stings. Okay, what happens? Sometimes an insect may bite you and it may be very painful, like bee. Okay, what happens when they bite you? It is very painful. Do you know why? Because they releases formic acid. Okay, and because of that acid, what happens? You feel so much painful and it becomes swelling. Is not it? So what happened? Medicine containing baking soda, okay, may give you relief from this pain irritation, okay. If sometime a honeybee bites you, try to put some baking soda if you are at home, okay. You rapidly put baking soda over the insect bite, okay. So what happened? The pain will come down, okay. It will neutralize the reaction. Now you see what happened? Acidity in human stomach. Sometimes what happens? Our stomach is burning. It's not. Do you know why? Inside our stomach there is dilute hydrochloric acid. Okay. So what happens? Usually it helps us in digestion of food. Okay. But what happens if we take too much of spicy food? The acidity level rises. Okay. So what happens? We feel what? Injection, burning in our stomach. So what we can do? We can take antacids. Okay, usually found in medical store. They will give you antacid like Digene. Okay, what it will do? It will neutralize the reaction. Just now we have seen what happened when acid react with base. What happens? It produces salt and water. Is not it? That is what neutralization reaction. Is not it? So in this way they neutralize. Okay. Now, preventing tooth decay. What happens is, when we eat too much of sweets, okay, the bacteria inside our mouth decompose that sweets into lactic acid. And you know what will happen? The lactic acid will corrode our teeth. So, we must brush our teeth with good toothpaste, usually containing fluorides. This fluoride are what? Base. Okay, so what happens if we brush our teeth with that toothpaste? It will neutralize the reaction. Okay. Now treating waste from factories. What happened? You see, from factories, okay, several waste comes out and they are acidic in nature. It's not it. So what will happen if they throw that waste in water? The life of aquatic animal will be harmed. It's not it. So what they do when the waste come out of these factories, they use some bases, okay, and neutralize the acids, okay, and later on what they discharge it into water, okay, so that the waste will become less harmful. Now treating the soil. As I told you earlier also, what happens? Sometimes the acidity of soil is too much, okay. In that case what happens? The plant will not grow, okay. So neutralize happens? Sometimes salt lime are used. They are mixed with the soil to neutralize the pH of the soil.